Alright, so in this video, I am going to be covering the topic graphs of functions. Now, when I say I'm going to be covering the topic, I'm going to be giving you all the key insights and all the type of questions that you may come across. So when dealing with this topic, so again, I'm not making big claims that this is the first and the last thing you guys need to watch. This, however, will cover all the key concepts, and the reason why it's taken me so long to make this video, I posted on my Instagram and YouTube that I'll be making this video, but the reason why it took me so long is because I wanted to just highlight all the key concepts and then mark those on past paper questions also, and I've done exactly that in this PDF. So I'll make sure to share this PDF with you guys. I'll share a link below. And yeah, so let's get straight to it. Now, one thing I want to say straight away is that you can draw, in fact you should draw a graph using a pencil. Okay, it's written at the very first page of your question paper that you may use pencil or for diagrams or graphs that you have to make. Okay, so that's out of the way, I hope. Okay, so there are a couple of main concepts, not a couple of main concepts, which are like a half a dozen main concepts are related to graphs of functions, or perhaps more. So I'm going to start with the very first, and this is how you'll notice that the question usually starts, that the first thing it's going to ask you to do is that it's going to ask you to find the missing value. You can see that I've highlighted it. That means that you'll be given a value of x, or maybe a couple of values of x, and you'll be asked to find the corresponding value of y. Okay, that's concept number one. I mean, one of the many few concepts that you'll be tested on. So a couple of things to take in regard or keep an eye on when solving questions like these is that at this point it's always best to use your calculator. Okay, there's no need to take unnecessary risk. Even if it's the very simple value, best that you use your calculator and then work it out, and make use of the bracket and fraction key where necessary. Okay, so if it's a function where you have to divide something, then make sure that you use the fraction key and use the brackets right. So I've just written an example here. So for example, if the function is y equals to x squared, although they're not so basic, it's usually followed by something after x squared. But suppose you want to find out the corresponding y value when x is minus 3, so make sure that you use the brackets right. I've here written the right way to do it and then the wrong way to do it. And over here, next step also, you've seen that it's always best to use the bracket key. So I've written here the right way to do it, although there could be many wrong ways to do this. Okay, but the whole idea is just use your calculator and make brackets, use the fraction key where necessary. So that's one concept. And then we come to sketching. So when you're sketching, make sure it's a smooth and a freehand curve. Yes, it needs to be a curve. Okay, you don't need to join all the points using a straight line. So you can see here's on the left there's the right way to do it, and on the right there's the wrong way to do it. Okay, so you're not making a sketch or something. Okay, you're drawing a curve, so it has to be smooth, it has to be freehand. Of course, you can take breaks in between, like for example, you can first join 2 points or 3 points and then take a break and then start from where you stopped. But you don't have to what's the word that I'm looking, overlap. Yeah, that's the word that I'm looking for. Okay, you don't have to overlap again and again, because that way you'll end up with something like this, which, I mean, looks cool, to be honest, but it's wrong. Okay, and plus you're gonna have a extremely hard time to read values, which is what the question usually is followed by, that you'll be asked to find the corresponding y value or when x is equal to something, or maybe the other way around. Not always, but usually. Or sometimes, in fact most of the time, you'll be asked to draw a tangent, which again, if you have a situation like this, so it's going to be extremely difficult. And then number 2 is that make sure to read the scale and carefully and plot accordingly. So one thing that I like to do is that first I want to get an idea of what the scale is like. So for example, if there's let's say 1 centimeter is representing 2 units, so I want to 1 centimeter is then further split into 10 boxes. So I want to get an idea first that what each little box represent on the x and the y axis. Okay, and the easiest way to do that is to take the number of units and then divide it by the number of small boxes you have in between, so you know exactly that where you need to mark maybe 2.5, 2.8. Okay, so that's something you should do beforehand. And then there's a very important concept, which is how to find the gradient using a tangent. So again, I've written here the correct and the wrong way to do it, and a couple of instructions you need to follow. So it should touch the curve only once, and it should touch it at the point where you're supposed to find the gradient. And the distance from the curve before and after should be equal. Now this is something that not a lot of people know, but an ideal tangent is, for example, over here you can see that the distance, this is the point where we've drawn the tangent, and the distance of this tangent from the curve, after and before the point where the tangent is made is equal. Okay, and that's what makes it an ideal tangent. Although one thing I should mention is that you'll always find that there's a certain range of acceptable answers. Okay, so if your answer is falling inside that range, then it's acceptable, and that range is usually very accommodating. Okay, but this is something you should never really count on. Okay, if it's inside the range, that's great. If it's not, then don't just count on it. Okay, then you're gonna lose a mark. And then this is a concept which is not tested so in such a straightforward manner. It's finding x when y is equals to a certain value, or y when x is equals to a certain value. And again, you need to read the graph carefully and make sure that you interpret the scale carefully. And if you do that at the very beginning, you're not going to have a difficult time over here. And then there is using the graph to find the solution of. This is something that I want to pay extra attention to, and I have a couple of examples for you guys. Okay, so we're going to cover this separately in this video, and the next video I'll be doing some past paper questions for you guys. And then there's a concept where you have to draw another line. Okay, so we'll cover that also once we're doing past paper questions. And then there is another concept where the question tells you that the x coordinates are basically the solution to the curve and some other line, and then it's going to give you a certain equation and not tell you what the coefficient of x is, or what the constant is, or what the coefficient of x squared is. So what we do is we basically compare our coefficients and find the missing values. Again, something that we're going to cover in this video only. Okay, so here's one example. This is an example that I've taken from the book. It's not a past paper question, I should mention that. And let's see what it says. So I've skipped the whole curve sketching part. This is something I want to focus on, and this is basically when the question will tell you by drawing a suitable straight line, or perhaps it can say that use your graph to find the solution to the following equation. Okay, so if you have to use your graph, that means you have to draw a suitable straight line, or sometimes the question is going to be very straightforward and it's going to tell you that by drawing a suitable straight line, solve each of the following equations. And solving an equation which is in terms of x basically means finding the x value. Okay, so this is the equation of the curve that we would have made, okay, if this were a full-length past paper question. So I should mention here that this right here is the equation of the curve, which we've already drawn. Okay, and then I have to use, if I want to use my graph, that means I have to use the equation of the curve. And if I want to use the equation of the curve, that means in order to solve this equation, in order to do the first example, either the left hand side or the right hand side needs to be equal to the equation of the curve, something that we've already drawn. And if you want to know what suitable line that you have to draw, what you're going to do is you're going to follow these steps. You're going to make sure that the side which is very close to the equation of the curve is somehow brought equal to the equation of the curve by doing some arithmetic, maybe adding something, maybe subtracting something, maybe multiplying the both sides by something. And then once you've done that, once the left hand side is actually equal to the equation of the curve, the next step is that you replace the left hand side, or whichever side that's equal to the equation of the curve, by y, because that's what it's equal to. You can see over here, and then see what you have on the right hand side. Okay, so just bear with me and you'll find out exactly what I mean. So if I want to bring this equation equal to the equation of the curve, let's have a look at it step by step. So as far as the equation of the curve goes, we have 1 over 4x squared. We have 1 over 4x squared here also. Okay, so far so good. Then you have a plus 8 upon x. That means you have a plus 8 and you have a plus 8 upon x here also. That again means so far so good. Now, as far as the equation of the curve goes, you have an extra minus 9, and over here we don't have that. Okay, so if I want to bring the left hand side equal to the equation of the curve, that means what I will have to do is that I will have to subtract 9 from both sides. And when I do that, here's what I get. I get 1 over 4x squared plus 8 upon x minus 9, and then 6 minus 9, which is equal to minus 3. Now the objective of doing that, okay, the objective of doing this is so that the left hand side is equal to the equation of the curve. And why do we want it to be equal to equation of the curve? We want it so that we can replace it with y, and y is equals to minus 3. Now when the question said by drawing suitable straight lines, this is the suitable straight line that we will draw. Suitable straight line that we will draw. Y equals to minus 3, it's going to be a horizontal line, and it's going to be parallel to the x-axis, and it's going to cut the y-axis at minus 3. And then this line will cut the curve at a certain point, or perhaps points, and then we will read those x coordinate, or perhaps coordinates of intersection, and those coordinates, those x coordinates, will be our solution. Okay, so that was one example. Now let's have a look over here. Again, here if we analyze, we have 1 over 4x squared in both, we have plus 8 upon x in both. what's missing is the minus 9, so we'll do minus 9 on both sides. The second you do that, the left hand side looks like 1 upon 4x squared plus 8 upon x minus 9 equals to x plus 4 minus 9, so that's x minus 5. So y is equals to x minus 5 is what you're looking at. So what is the suitable straight line that you're going to draw? It's right over here, y equals to x minus 5. And to draw a line where you have x and y both involved, it's always a good idea to make a box. And one thing I want to mention is that when you're drawing a straight line, make sure to take the values accordingly. So for example, if you have a scale or on the grid, if for example you can take only positive values, so don't end up plugging in negative values here. So for example, if my scale is on the x and the y axis, sorry, not scale, the grid, on the grid I'm only provided values of x and y from 0 onwards. Okay, so there's no point in plugging in minus 1 here, because where am I going to mark that minus 1, right? So instead what I'll do is I'll take 1 2 3 x y. So these values over here should be in what should I say, should be taken according to the grid. Okay, so these values should be taken according to the grid provided, or if you want to elaborate this, according to the values that you provided on the grid. Okay, or the range of x values. Yeah, I think the correct word here is range, the range of x values that you have on the grid. Okay, so yeah, and then of course you're going to plug in these values, you're going to find the corresponding y values, you're going to draw the suitable straight line. So this will be a positive sloping line, which means it's going to go like this, and it's going to cut the y-axis at minus 5, and then it's likely to intersect the curve at perhaps a point or multiple points, and that the x coordinate of those points or point will be your final answer. Anyway, then we have part 3. So in part 3, what we can see here is that we have 1 over 4x squared on both sides. All right, so far so good. You have a minus 8 upon x. Ideally this minus 8 upon x should have been on the left hand side and should have been positive. So we're going to bring this over to the left hand side, and when I do that, this is what it looks like: 1 upon 4x squared plus 8 upon x. Okay, so this 8 upon x is now on the left hand side, and this 2 upon x should have been on the right hand side. So that means we have 15 as it is. Now 15 is joined by a minus 2x. Now in order to complete this and bring it equal to the equation of the curve, you can see that we have to subtract 9 from both sides. So that's what we do. And when you do that, this is equal to y, which was our objective. And 15 minus 9 is what? Is 6. So is it? Yeah, of course it's 6. 6 minus 2x. So this is the suitable straight line that you're going to draw. Again, you're going to plug in x values, you're going to find the corresponding y values. When you're plugging in x values, make sure that you do it in accordance to the range of x that's given to you in the grid. And yeah, do that and find the point of intersection. The x coordinates are the point of intersection, and you're good to go. Okay, so I have a few examples over here. I'll post the answers to this on my Instagram. Okay, this is something I'd like you guys to try it out, which is why I'm not going to solve it over here, but I will post the answers to this on my Instagram, so you guys can check it out from there. Anyway, so moving on, this however is one example that I will do for you guys, because this is slightly more complex. So it says here that y is equals to 12 upon x plus x minus 6, and it says use your graph to obtain the solution of, and you can see that the equation that we have over here and the graph that we've plotted, they're kind of not completely different, but maybe your immediate reaction would be that they're nowhere close to each other. Okay, so how exactly do we do that? Okay, so we have a look at it step by step. So first thing I'm going to do is, I can see that there's a 12 here and there's a 12 here. Okay, and then there's an x, and then there's an x squared here, sadly, and then this is equal to 10x. So we're not so worried about equals to 10x right now. Okay, but what I am worried about right now is how come you have a 12 upon x in the original equation and just a 12 in this part. So first of all, I'm going to write this nicely. So I'm going to write this as 12 plus x squared equals to 10x. Now, at this point you got to think, okay? You got to think, how can you bring, sorry, equals to 10x, my bad, yeah. You got to think that how can you bring the left-hand side equal to the equation of the curve? So, hopefully you found the answer by now, but if you haven't, nothing to worry about. So you can see that there's a 12 here and 12 upon x here and just a 12 over here. So how can you bring it equal? Simply by dividing by x. So once you divide by x, the left hand side, that means you also end up dividing the right hand side by 6. Now what I would like to do is I would like to write the upon x separately. Okay, it's a common denominator of 12 plus x squared, so that means I can write it separately also. So 12 upon x plus x squared upon x equals to 10x upon x. Now the two x's get cancelled out. Now this is now very close to the equation of the curve. It's not equal to the equation of the curve, but it's very close to. So what's missing? The missing piece of the puzzle is the minus 6. So we're going to do that on both sides. When you do that, the left hand side becomes 12 upon x. X square upon x then simplifies to plus x. Minus 6 equals to 4. Now the left hand side is equal to the equation of the curve. Not coincidentally, this is what we wanted to do. And well, when the question said use your graph, so we're going to take into account the equation of the curve, which is already, the curve is already plotted, and then we're going to plot y equals to 4. That's a horizontal line parallel to the x-axis, cutting the y-axis at 4, and the point at which the curve and the line meet, the x-coordinate of that will be the solution. Sometimes the question will ask you for the y-coordinate also, but if it's a horizontal line, you guys know very well that the y-coordinate will be fixed. In case you don't, you know that if a line is horizontal, the y-coordinate, the y values don't change. It's only the x values that change. Okay, so gotta keep that in mind. Anyway, now, so here again some key points for you guys. So, and this is something I've already elaborated on, by the way. Make a table to draw the other line when you're asked to do so, and take values according to the grid provided. Again, something I've already elaborated on. Now here's something that's very often tested. Okay, in fact it's right up there with tangent, and it says, the question will say that the x-coordinates are solution to, and then you'll be given a certain equation. Okay, and then you'll be asked to find the missing values of the equation that you're given. Again, I'm just about to solve the question, so you'll find out exactly what I'm saying. So a couple of steps to follow when doing a question like this is that you need to first make y the subject in both the equations. If you haven't, you need to equate the two because you've made y the subject in both, and you need to bring it in the form that's mentioned in the question, and then compare the coefficients. So I'm going to do just that, and this is an example from past paper questions. I wish I had mentioned that what year this is from, but anyway, this is a past paper question. So over here you can see that you're given the equation of the line y equals to 4x plus 3, and the equation of the curve y equals to x cubed minus 3x minus 1. The question says that these line and the curve can be used to solve the equation x cubed plus ax plus b. Find the values of a and b. Okay, so how did the question get this? Okay, where did this come from? This came after equating the two and bringing it in this form, and that's exactly what we're going to do. Luckily here we don't have to make y the subject because that's already been done for us. So I'm going to straight away jump to step 2, which is that I'm going to equate the two equations. So I'm looking at 4x plus 3 equals to x cubed minus 3x minus 1. Now I want to bring it in the form that the question has, so it's easy for me to compare. So I'll keep x cubed on this side and take everything else over to the left hand side. So that means I have 4x plus 3x and plus 1. Yeah, let me just double check, and a plus 3 from before. Yeah, so let me make room for that. Oops, sorry. Yeah, plus 3 from before equals to x cubed. Okay, so 4x plus 3x is going to be 7x, and 1 plus 3 is going to be 4. This is equal to x cubed. If I write it the way the question wanted me to, so that means x cubed is equals to 7x plus 4. Just give it a double check. So 4x plus 3x is 7x, 3 plus 1 is 4. Yep, there you go. Now the whole idea of doing this was so that I could compare it with x cubed equals to x plus b, and now I'm looking at a is equals to 7 and b is equals to 4, and there you go. This is your answer, and this is the method that you need to follow whenever you're solving a question like this. And trust me, questions like these are something that you're going to come across over and over again. Anyway, so now I have some past paper questions prepared for you guys, which I'm going to solve in the next video. I promise you won't have to wait that long for the next video. So yeah, see you guys in the next video. Take care. Bye bye.